First one, what you have here is you have the binomial square expansion rule, right, which is 1 to 1 if you're thinking in terms of the pattern of coefficients, or you can think of it as just taking your first term, squaring it. Now notice I can carry the negative along with it. And we square the first term. 5 squared is 25x squared. Then we take double the product of these terms. So 5x times a negative 2 is negative 10x. Double that, we get minus 20x. Our last term is negative 2 squared. Negative 2 squared is plus 4. And the last thing you do need to do is distribute this negative through. Again, order of operations says do the exponent first and then multiply. So if we distribute that negative through, change the sign of each individual term, and we have our solution. Now, when you write a polynomial, you can have negatives as your leading coefficient. It's when you write them as factors that I don't want the negative there, I want it factored out. So this is the correct form right here. In this second example, we have a binomial cube. So this is the one that in which the pattern is 1, 3, 3, 1. Again, if you needed to recreate the patterns, you could use Pascal's triangle. Here's the pattern for a binomial square from up above. Here's the pattern for the binomial cube. So the way that I would approach this is I would set up my pattern of coefficients, 1, 3, 3, 1. I'd take my first base, 2x, and I'd start from left to right at the highest power, which is 3, and then reduce it by 1 to 2, and then to 1, and then to 0, so I leave it off the last term. Do the same thing from right to left with my second term, negative 5. I'm going to start from the right, cube it, square it, to the first, to the 0, and then I'm just going to simplify what I have. Okay, so here I'm going to cube the 2, cube the x. Here I'm going to square the 2x, so it becomes 4x squared. And if I multiply these through, 4 times the negative 5 is negative 20, times 3 is negative 60, x squared. Here I'm going to square my negative 5, it becomes a plus 25. And so when I multiply through here, I wind up with 2 times 25 is 50, times 3 is 150, so I get plus 150x. And then at my final term, I'm going to cube negative 5. I get negative 125 is negative 5 cubed. And so I wind up with my expression as it is. Okay, now, if you're looking for patterns for the binomial cube, if the middle term, or if the sign in between is negative, then they should alternate signs. If the sign in between is positive, then they'll all stay positive. Right? So this fits that pattern of alternating signs as well. Right, our last expansion pattern is the sum and difference of terms. It's a plus b times a minus b. This expands into the difference of their squares. So we're basically taking 4 root 3, squaring it, and we're subtracting 2 squared. Okay, it just, again, expands into the difference of those squares. And when you expand these, you do have to square both parts. So we square the 4, that gives us 16. Square the root 3 is just the 3. And then here we square the 2, and we get a 4. Okay, so 3 times 16, if you take 3 times 10 is 30, 3 times 6 is 18, 30 plus 18 is 48, minus 4, and when we combine those terms, we get our final answer of 44. All right, so in this first one, what you want to do is you kind of want to group them together. So if you look at these two first degree factors, so factors in which the highest degree term is 1, compare that to the second degree terms in this other factor. So let's combine those first. Well, you should be able to recognize that these fit the pattern of the sum and difference of terms. So they're going to be expanded into the difference of their squares. So if you take the first term, 2x, and square it, minus the second term, y, and square it, you get the factors, again, square the 2, square the x, minus the y squared. So you can expand these two binomial factors into this one single binomial factor. And if I drop down the second factor here, what you should also be able to realize is that these fit that same pattern, sum and difference of terms. A minus b times a plus b. Therefore, those are going to expand into a squared minus b squared. So if we take the first, when you look at those two, we take the first 4x squared, square it, minus the second, the b value is y squared, and square it. What you can then simplify is, again, we're squaring both parts of this base. Square the 4 is 16, square the x squared. When you take a power to a power, you do what with the powers? Multiply 2 times 2 is 4, minus y to the, again, 2 times 2 of 4. And so this would be your expanded form. It reduces all the way down to just a single binomial. All right, the second one is just a simple FOIL or distribute type of problem. There's no special patterns, no common factors to remove. So when you FOIL this, we take the product of our first terms, multiply the 3 times the 5, and the x times the x. We get 15x squared. Take our outer products, 3x times a negative 3 is negative 9x. Now we distribute our second term, which is our inner product. So we take 1 times a 5x is a plus 5x. And then our last term is 1 times a negative 3 or minus 3. And so when you simplify what you have, you get 15x squared, combine our like terms, which yields a negative 4x, and then the minus 3 just drops down. And so this would be the expanded form of that second set of factors. All right, the final example is a binomial cube. So it requires the expansion pattern for a binomial cube, which is 1, 3, 3, 1. Again, if you don't remember it offhand, you can recreate it using Pascal's triangle really quickly. Okay. And if you're able to use this pattern, what you can then do is just start with your first base, x, and we're going to take that base, and from left to right, we're going to take it to the highest power cubed, and then reduce it each one as we move to the right. So squared, and then to the first, and then to the 0, so we can leave it off the last term. And then we take our second base, which includes the sign, so plus 1, and we're going to take that 1 starting from the far right and working to the left. We're going to take that base and reduce the power each one, so power of 3 squared to the first and leave it out. And then just combine your like terms here. So we cube the x, square the x in this case, so plus 3 times 1 or 3x squared. Here we square the 1, which is just a 1, so plus 3x. And then our last term, cube the 1, which is 1 times 1, and that gives us our answer. And now we have an alternative method for working with a binomial cube. If you have difficulty working through the pattern, what you can do is you can simply extend this as x plus 1 times x plus 1 squared. And what you can do is you can use the binomial square pattern for this second set. The binomial square, again, is either 1, 2, 1 pattern, or you take the first term and square it, double the product of your terms. X times 1 is x. Double that, you get plus 2x. And your last term squared is plus 1. And what you could do, if you, again, don't like working with the patterns, is just distribute this out. So if we distribute through, we get an x cubed plus 2x squared plus x. Move to the next term, plus x squared plus 2x plus 1. Combine our like terms straight down these vertical columns. X cubed plus 3x squared plus 3x plus 1. And notice it's exactly the same as what we got using the pattern. It all depends what your preference is or what you're comfortable working with.